Hello everyone. So in this video, we are going to continue talking about Zeno of Elea, and we'll talk about his paradoxes of plurality. So as we discussed in the last video, so the way Zeno argues is by using a kind of elenchus. So he uses this kind of argument from absurdity or reductio ad absurdum, where he takes common opinions and then he turns it around and shows how these common opinions would lead to a contradiction, and thus proves the point that which is the opposite of whatever hypothesis he took up. And with Zeno of Elea, actually, you will see that he does it with a lot of rigor, a great deal of mathematical rigor, where he takes things which stand at the core. Let's say when he's making these arguments against plurality, he takes sort of certain arguments which stand at the core of the notion of plurality, and he shows how those the assumptions themselves on which plurality is based would lead to contradiction. And so he is using a very sort of sharp critical argument against common opinion, and that's why they are paradoxes. They are paradoxa. They are against common opinions, right? So he has we have testimonia from Proclus, I think, that says that there were more than 40 such paradoxes recorded, and the few about plurality that we have all come from Simplicius, his commentary on Aristotle's physics. Aristotle's physics is where he discusses the paradoxes of motion. At least that's where I found them, and we'll look at paradoxes of motion in the next video. But here we have these couple of paradoxes which are very sharp, which really make you think, and they are based on like a mathematical sort of reasoning about the nature of the world. And in fact, the later sort of physicists, like the atomists, and the earlier, well, if you call them physicists at all, the Pythagoreans, it sort of stands sort of to contradict sort of the earlier kind of notions of plurality from the Pythagoreans, showing that it is absurd. The Pythagorean notion of plurality itself is absurd. And then it also contradicts sort of the future, but although in the future the atomists will try to sort of make a stance against Zeno. I think Zeno was, as I said, Parmenides, Zeno, dynamite. They posed this big challenge to the physicists, to all the natural scientists, and so the atomists came up with what they thought of as a solution to Zeno's paradoxes and to Parmenides's and Zeno's challenge against plurality. By saying, eke world, like look at the world and you can see that there is plurality, and it's not, and their argument is not as simple as, I can move, so there is plurality. Anyway, let's look at Zeno's arguments first, right? So I'll read out fragment 1, 2, and 3, and discuss it while I read it out from Zeno, right? Which deal with magnitude and number of units, which gives us an idea of plurality. Okay, right. So he says, if there is a plurality, sorry, I'll just make it slightly bigger for me. If there is a plurality, things will be both great and small, so great as to be infinite in size, and so small as to have no size at all. So this is the challenge, right? The challenge is that let us assume, if you put it in that style of argument, the hypothetical argument, let us assume that there is plurality. And then he says the conclusion, and then we'll see his proof of it after that. The conclusion then would be that things are both infinitely large or infinitely small. If there is plurality, then everything would be both infinitely large and infinitely small. How? Because they will be both great and small. So great so as to be infinitely big, and so small as to have no size at all. Now this is a real paradox, right? It's a real problem that because we look at the world and we don't have this problem, right? So why is he sort of claiming this? How does he come to this conclusion? So he says, and it follows a very nice proof structure. He says, if what is had no size, it would not even be. So if you're talking about being, and if it did not have size at all, then it would be of zero size. It would not be at all, right? And in fact, this zero that we have, like think of it now as like a null, a zero, a void, right? So if you add this zero to something, so he says if it were added to something else that is, let's say you add it to something that is, it would make it no larger, it would not make it any larger than it was. For being no size at all, it could not, right? So if you are saying that being is of no size, then if you add it to another being, like you can add 0 plus 0 plus 0 plus 0 plus 0, you would still have 0, nothing would be added. You would have no magnitude at all. So for being no size at all, it could not, on being added, cause any increase in size, of course, right? You could not go from, you could add like infinite number of zeros and you would still have a 0, right? And so what was added would clearly be nothing, yeah? Again, when it is taken away, so if you subtract a 0 from something, the other thing is no smaller, just as when it is added, it is not increased. Obviously, what was added or taken away was nothing, right? So this what is, if you think of the single what is, this being that you're talking about, and you're talking about, why are we talking about this? Because we're talking about plurality, right? So plurality is, of course, composed of many what is. Right, now the question is how many what is those are and what size they are, yeah? What is the size of this what is? Is it composed of many units, but many units of 1, many units of 0? So we are going first with the assumption that it is composed of many units of 0, right? Like the set theorists later, Cantor, for example, would have this, where you have the null set. You have like the null set, and then the set of the null set is the singleton, which is 1, and the null set and the set of the null set would be the number 2, and so you would have, infinity constructed out of nothing. Cantor does it brilliantly, and that's what you have in set theory precisely. But here, what he's talking about is this simple addition that you're doing. So you have this null, you add null to null, you add 0 to 0, what do you get? 0. You add 0 to 0 to 0 to 0 to 0, you get 0. You subtract 0 from 0, you get 0. You subtract 0 from 0 from 0 from 0, you get 0. Right, so it does not seem to have any magnitude, right? So we cannot say then that, because then you will have nothing. You will only have what is not. It is not what is at all, because what is, and what is not, if you remember Parmenides, right? So if what is has no magnitude, and even if you have a plurality of things with no magnitude, you will not get anything. So let's look at the other sort of side of it. He says, but if something is, right, then it must have some magnitude, right? If it is, if you're not saying it is not, because remember the null set or the nothing, or whichever way you want to think of it, anachronistically as a null set, or in that time as a unit having no magnitude, so as a 0. So, but if that is, then it must have some magnitude, right? So if it has some magnitude, then one part of it, he says, must be at a certain distance from another part, right? And the same argument holds about the part in front of it. It too will have some size, and some part of it will be in front. And it is the same thing to say this once and to go on saying it indefinitely, for no such part of it will be the last, nor will one part ever be unrelated to another. Right, so now he's doing something else. Now what he's doing is that he's talking about this thing with magnitude, and he's talking about it now spatially, geometrically. He says if it has some kind of a magnitude, it has shape, size and depth, let's say, right? Then if it has size and depth, then one part of it will be separate from another part of it, right? But if if that happens, then it has a surface, and then it has an inside of the surface, right? It has an outer surface and an inner surface, let's say. But then the outer surface and the inner surface will go ad infinitum, and that would make it infinitely large in magnitude, right? If you want to think of it arithmetically, as we were doing earlier, then think of it this way, that if it is sort of 1, like the number 1, right, then you can divide it into something smaller than it And so you have the limit which makes it number one and something less than number one. So it sort of it would make it bigger and bigger and bigger. You know, a collection of units. Let's say a plurality is made of units. So how many ones is that plurality made of, right? So what's going on is that with the outer surface, here he's talking about surfaces, so let's stick with his argument. So he says any outer surface of the thing would be itself an inner surface ad infinitum, and then it would be infinitely large, right? So you have these two problems. One is that if it has no magnitude, then an infinite number of parts with no magnitude will never add up to a magnitude. But if it has magnitude, then it will have an infinite magnitude, right? Because then it would have a magnitude which will be an inner surface and an outer surface, and the outer surface will be the inner surface, you know, so that kind of a thing, right? So I'll just continue with Zeno. I've not read out the whole fragment, actually. So he says, yeah. I don't know which part I stopped in, so let me just read it out again, you know, because it's anyway a bit confusing. So he says, if it has magnitude, let's say, each thing must have a certain size and bulk, right? Size and depth kind of a thing. And one part of it must be at a certain distance from another part, the outer surface from the inner surface, let's say. And the same argument holds about the part in front of it. It too will have some size, and some part of it will be in front. And it is the same thing to say this once and go on saying it indefinitely. So it is again this infinite regress problem. For no such part of it will be the last, nor will one part ever be unrelated to another, right? It's all the same part sort of sticking, and then you have, it just gets bigger and bigger once you start thinking about it. So he says, if there is a plurality, things must be either so small so as to not be there at all, or so great so as to be infinitely large, right? And in fact, it should be both. Why? Because anything that you think of, it's either indivisible, infinitely divisible, or divisible, right? So you have this idea of infinitely divisible and divisible. But if it is divisible, then it is infinitely divisible, right? So because at what point should it stop? If I say anything that you find out here, any substance you find, it's divisible, then you divide it and divide it further and divide it further, and you will get to smaller and smaller and smaller parts, and you would get to infinite divisibility. And in fact, you will get to quantum mechanics probably, you know, at the quantum level, you know, at what point do you stop this infinite divisibility of something? But then, if it has any magnitude, you know, and it's not going to reduce to nothing, you know, if it is not composed of nothing, as Cantor's sort of universe is, then you will have an infinitely large sort of object, right? I mean, so this was proved, like this was solved in some ways by Leibniz and calculus, you know, so this kind of the idea of tending towards zero and tending towards sort of infinity. In fact, I think the Stoics also came up with something pretty similar to calculus when they were talking about I think did they talk about Zeno's paradox? I don't remember exactly, but they talk about a cone, and they say we cut the cone in half, and then you have the lower half and the upper half, and now they show that that's why reality is continuous, in the sense that how much bigger then the upper half of the cone is the lower half, because you've cut it at one surface, which means that they should be the same size, but if you see the cone is increasing, right? It goes this way. So how much bigger is it? So these are things, these are solutions that, you know, people came up with from ancient times onwards, and which is why Zeno is so interesting, because he really does challenge people to this problem of having to come up with a solution, you know, of proving that there is plurality, or proving that there is continuity, or, you know, of motion or something, right? Anyway. So he says, if there is a plurality, things must be both small and great, so small so as to have no size at all, and so great as to be infinite in size. And then we have fragment 3, where he says, if there is a plurality, things must be just as many as they are, no more and no less. And if they're just as many as they are, they must be limited, right? So if you have a plurality, and this is the other one that I was talking about, the mathematical one, you know, 1, 2, 3, 4, 1, 1, 1, 1, 1. So if it is composed of many units of some magnitude, let's say, right, then it needs to be composed of a limited number of parts, right? Limited units of that magnitude. But he says, but if there is a plurality, the things that are infinite. For there will always be other things between the things that are, right? So if there is a plurality, then you say that it's composed of units, but that unit is itself divisible. There will be other parts of divisibility. You know, in a continuity, let's say you have a continuous set, you have a set of real numbers, if you want to think in terms of numbers. You know, at what point do you make a cut and you say that here, you know, this unit that I found is the indivisible single unit? Well, actually you can cut it further. Yeah. And you will get like even more sort of real numbers that will sort of pop out from inside. So at what point will you say, I mean, so the set of real numbers is composed of, well, infinitely many, you know, real numbers, but it's also composed of exactly that number of real numbers, right? Not more and not less, you know, it's the same size. The problem, I suppose, of biunivocal correspondence between the set of natural numbers and the set of real numbers, you know, how do you make that biunivocal correspondence? So it is how much bigger than the set of natural numbers is the set of real numbers. I mean, that is the problem of the continuum hypothesis, you know, it's like, how much bigger is it? Anyway, let's not go into that. So he says, if there is a plurality, things must just be as many as they are, no more and no less. And if they are just as many as they are, they must be limited. And if there is a plurality, the things that are infinite, the things that are infinite, sorry, for there will always be other things between the things that are, and yet others between those. And so the things that are infinite, right? So it is both finite and infinite, right? So you let's say you take a finite number of, you know, plural things, and you say there are just 10 things. But those 10 things, then, you know, and once you start looking at, you move into the real number territory and the continuum territory, become infinite number of things. So it becomes pretty impossible to deal with this, with this business, right? So basically he's showing that the accepted notions of plurality, you know, they rest on premises that make them absurd, you know. In fact, let's go to the next one, which is also from Simplicius, I think, where he says that as Eudemus records, Zeno used to say, he used to try to prove that it is impossible that existing things should be a plurality by arguing that there is no unit in existing things and that plurality is a sum of units, right? So again, we have this problem that if, you know, plurality is a sum of units, then how do you, like, okay, so the next one actually he says that Zeno used to argue that if anyone could explain to him whatever the one was, this unit that composes plurality was, then he will be able to account for existing things, right? Now the problem is that there is no one, you know, in a plurality. You have one big one, you know, which is a single thing, you know, which is this monomenos, you know, this one single unitary thing. But if you're thinking of plurality as composed of many units, a sort of number atomism of the Pythagoreans, for example, then what is this one? And it relates to the first fragment that we read, where he says that, well, what size is this one? If there is a one, then what size is this one? Is this one, you know, infinitely divisible and therefore zero and has no magnitude? And if it has no magnitude, then how can it compose things with magnitude? But if it does have magnitude, what is its outer edge and inner edge, and how big is it? And does the outer edge also have an outer edge? And does the outer edge also have an outer edge, which will make it infinitely big, right? So you have again this problem of divisibility. Basically, you need an infinite number of indivisible units, right? But these indivisible units, but plurality, the idea itself says that reality is divisible, right? Which means that these indivisible units, let's say whatever you call an atom. Atom is the word which later the atomists would use, which means cannot be cut, right? A and Thomas, right? So it cannot be cut. Now this thing that cannot be cut then, what is this thing that cannot be cut? How big is it? How big can something be for it how small rather can something be for it to not be cut, that you cannot cut it further. So the problem is that if it can be cut, if it is divisible, then it is infinitely divisible, and infinitely divisible to the point that nothing can be called a unit. You will not find a unit at all, right? Because anything that you call a unit will be further divisible, right? And therefore, as he says, plurality is a plurality of units. It is composed of things that you cannot find, it's impossible. In fact, I tried to make this kind of a connection between the Pythagorean number atomism in Zeno and then Anaxagoras and Atomus, because all of them talk about this, and Anaxagoras and Atomus we'll deal with later. But just to give you an introduction to this, so with Pythagoreans, if you think about it, you have the arithmetic unit, which turns into this geometrical point, which turns later for the atomists into this physical atom, right? And also for Pythagoreans, the number atomism is basically you have the arithmetic unit, which turns into a geometrical point, which turns into a physical atom. Now, the problem is that you cannot find this arithmetical unit at all, right? This unit, anything that you call a unit is indivisible by definition. The idea of the unit is itself, it is composed of indivisibility, right? And any geometrical point that you name, because you're naming it in the world, that point is infinitely divisible, as Zeno claims, right? So this thing, which is both an arithmetical unit, which is indivisible, and a geometrical unit, which is infinitely divisible, right, is both then finite arithmetically and infinite geometrically, right? Because geometrically then, it contains an infinite number of arithmetical units, and it contains infinite points in that sense. So any point that you find is a point of infinite magnitude, which is either nothing, very small, or it is infinitely big. Yeah. So the problem actually that we have with these is moving between arithmetic to geometry. I think that's one of the ways that commentators have understood it, is that, from moving from an arithmetical idea of a unit which is indivisible to a geometrical idea of unit which is divisible, of a point, sorry, which is divisible, will lead you to this contradiction where this point is both of no magnitude at all, a point with no magnitude, or a point with infinite magnitude, right? Because if that point is further divisible, then it is sort of, like, what is it composed of? Like, I'm not going to repeat this whole paradox again, but you should get an idea. So, yeah, we'll talk about Anaxagoras and Atomus next time when we talk about them. So, what you have here then, in fact, with the first paradox, you have different interpretations. So I will read out from Kirk and Raven, actually, because he explains it very well. He sort of collects them very well. So he says that yeah. So G.L. Owen, who summarizes this, says the paradox. The paradox had two arms. The first began by arguing that the units in a collection can have no size at all, else they would have parts and be not units but collections of units. Right, so the units can have no size at all. That's the first part of the paradox, because if it had any size, then it would be then they would have parts, and they would then, if it has parts, then it has further units. It's further divisible. Right. The second began by arguing that, on the contrary, there cannot be anything that has no size at all. So the first part is to do with, units and parts, and the second part has to do with size and magnitude, as you saw. For there cannot be a thing which, if it were added to or subtracted from something else, would not affect the size of that thing, right? So you have that second problem. So this one, there are two interpretations. So one interpretation via Edward Zeller and then Ross says that this is an arithmetical, as we've been discussing, it's arithmetical and geometrical, but in these interpretations they take it as either entirely arithmetical or either entirely geometrical, and it's a good summary, so I will recite it to you. So the first one takes it as arithmetical and says, the many must be both limited and unlimited in number. Limited because it is as many as it is, no more, no less. Yeah. So if you have a plurality, it is numerically both limited, finite, and unlimited, infinite, right? Finite because it is the same number as it is. You know, the set. Like if you, it's somehow I end up thinking in terms of sets. So forgive me. I hope that helps you as well. So the set will be of a particular size, and that size is the size of that set. It's equal to itself. So it is composed of a certain number of finite parts. You know, so let's say the set of the numbers from 1 to 10 is composed of 10 units, in that sense. Yeah. Unlimited, however, infinite, because two things are two only when they are separated. In order that they may be separated, there must be something in between them. And so too between this intermediate and each of the two, and so ad infinitum. And so what happens is that as soon as you start thinking of it as, oh, it's a limited set of 10 units, you know, which in any case is already an infinite number of units, because you think of natural numbers as being size omega 0 or something, right? So once you start sort of cutting it up, like once you start thinking about it, you will find between each two numbers, you will find an infinite number of numbers, right? Because between those two, there are more units. So arithmetically, that means that it is both finite and infinite. It's both of one size and another size, right? Then, on the other hand, you have another sort of interpretation in which H.T.P. Lee writes, the second part must again make nonsense unless it is understood that the things in question are supposed to have properties of points on a line. So he's thinking of it geometrically, you know, points on a line. And he says that between any two points A and A dash, it is possible to take further points, you know, or A and A1, you can take points A2 and A3 and A4, and so ad infinitum, right? And so you have this sort of different interpretation where one of them is thinking about it sort of arithmetically, and one of them is thinking about it geometrically, but both of them work. And I think both of them can be derived from Zeno's sort of like argument. You can get both an arithmetical idea and a geometrical idea, and so it's a double paradox in that sense. And I suppose, you know, set theory does turn into topology, so you have this double paradox no matter you know, how you think about it. Then Conford wrote, the assertion that things are many probably covered the following propositions. First, that there's a plurality of concrete things, bodies capable of motion, such as our senses show us, and each of these concrete bodies is a number or plurality of units, right? So you're thinking both of everything as being composed of number, you know, there is a Pythagorean sort of way of thinking about things, but also in geometry, you know, it's also a kind of line geometry and space geometry, you know, both of them at the same time. So, yeah, I think we've talked enough about the arguments against plurality, and I can, the more I talk, probably it'll get more confusing, so I should probably stop soon. But basically, what is he doing? So he's showing that accepted notions of plurality that you have, you know, they rest on absurdities, they rest on these sort of, these notions of one and many of units which you cannot find. As he says, you know, if you could find me a unit, I will tell you about plurality, but you cannot find me the unit. Tell me what the unit is. And if you find the unit, tell me what size it is. Right? So, the thing with Zeno is that, as you can see, even with these fragments, we don't have anything stated positively. What he's simply doing is he's attacking. Right? He's basically saying that he's not saying anything about what a unit is. Basically he's saying, what would you call a unit? You know, if you believe in plurality, is it composed? What is it composed of? Is it composed of units? Then what is this unit? Is this unit sort of further divisible? Is it indivisible? If it is divisible, I have a problem. If it is indivisible, I have a problem. So I'll show you paradoxes everywhere. So long as as soon as you say that reality is composed of infinite number of units, there is a paradox, right? So in that sense, it can be taken as an anti-Pythagorean kind of a view. And in summary, you can have this sort of, if you think of like, you know, whatever we have, I mean, out of 40, we have like basically 2 or 3, whichever way you want to think about it. So you have these arguments that basically show that there are three ways in which plurality can go wrong. One is in terms of magnitude. If you talk of plurality, things would become infinitely small or infinitely large. In terms of number, it could be finite or infinite in number, limited or unlimited in number. So and that too in two different ways. Limited and unlimited in number arithmetically in terms of the number of units, but also geometrically in terms of number of points in a line, right? And the main thing that it rests on is the idea of plurality of units, and he's basically saying that you will not be able to find these indivisible units in anything, in thought and nature, it's impossible to find it, and that's where your whole notion of plurality goes wrong, right? So that's the first set of paradoxes. In the next video, we'll talk about the paradoxes, the more famous ones against motion. So thank you.